Okay, this is my project. I did it on multiple lights and circuits. For my motivation and context, my motivation is that we use circuits daily through power strips and outlets, and it's important to understand how they work to prevent electrical hazards and overloading circuits. We've explored this through class when learning about circuits, but I wanted to do my own experiment on it to explore more. So the question that I'm aiming to answer is, how does adding more lights to a circuit affect its brightness, current, and power? So for my setup, I did it on a PhET lab simulator. So I did one bulb in series, and then I added another one also in series, and then I watched the difference of the current and voltage from to through the bulbs, and then I did the same thing, but I did two bulbs in parallel. So for my calculations for parallel, I got an REQ of 5 ohms and I total of 1.8 amps. A voltage for the bulb was 9 volts. The current for the bulb is for one bulb is 0.90 amps, and the current or the total current is 1.8 amps. So then I calculated power, and I did that by multiplying the volts by the total current, which I got 16.2 watts for the total power, and then the power through each bulb is 8.1. For series, for the one with the two bulbs, we have an R total of 20 ohms. For the for the current is 0.45 amps per bulb, and then the voltage per bulb is 4.8 volts. And then for power per bulb, it's 2.025 watts, which then our total power is 4.05 watts. So here are my models. I have the circuit diagram for the two series circuits and the one in parallel. I have a system schema here of, this is just an example of the one in the series where the electric energy goes through the whole circuit. And then for the power box, I have the power box for series and in parallel, and between each bulbs, they're both even power. So for the analysis, when bulbs are in parallel, they don't lose brightness. When you add more in series, the current through the bulbs decrease as you add more to the circuit. When looking at voltage, parallel circuits give all 9 volts to the lights regardless of how many bulbs were added, while in series, the voltage per bulb decreases based on the amount added to the circuit. So I calculated the uncertainty here. So for series, the uncertainty for one bulb, the current is 0.90 plus or minus 0.13 amps. For voltage, it's 9 plus or minus 0.5 volts. And then for two bulbs, it's 0.45 plus or minus 0.06. And then for voltage, it's 4.5 plus or minus 0.5. And for voltage uncertainty, I just got that of like what the multimeter would be. And then for the current uncertainty, I calculated that. Just, you can see my calculations there. For parallel, I got a current of 1.8 plus or minus 0.3 amps. And for voltage, I got 9 volts plus or minus 0.5. It's the same thing. For sources of error, there are several. So one is that the light bulbs are not perfect resistors. They heat up, and when they do so, their resistance changes, so it wouldn't be a perfect 10 ohms of resistance. Another source of error is that voltage isn't always constant, and the last source of error that we have is through the measurements. Multimeters have a margin of error that can be calculated through uncertainty, so I did that in the last slide. For a conclusion, this project helped me better understand how circuits work in real life. It showed why devices in homes are wired in parallel so they receive full voltage and operate properly, while series circuits are less practical because adding components reduces their performance. This connects directly to my everyday life through the use of power strips, lighting, and charging devices, and helps explain how to use electricity safely and efficiently. Thank you.